So when we go to calculate areas, we're going to need to use something called our z-tables, or in this case, our standard normal cumulative probability table. This is in your textbook. I also uploaded a copy of these tables online, and then eventually when we take quizzes and tests where you need to find areas under the curve, I will provide this table for you. So it's something you'll need to use during test scenarios. So, our table. There's two pages to our table. One uses negative z-scores and one uses positive z-scores. Reading this table, it comes down to having our z-score and having a value to 2 decimal places. So we'll be rounding our z-scores to 2 decimal places. And then we can use that to read the table. So maybe there's a whole number part to our z-score, maybe there isn't, but basically for our z-score, where we'll have number, decimal, number, the first 2 pieces, so the ones place and the tenths place, is going to be read along the left-hand side of the table. So we'll find it over here. If it's negative, we'll use this table. If we go to the next page, this is where we have our positive values coming through. Then from there, to fill in the blank of our last decimal place, that part is read along the horizontal. So that's where we'll find our hundredths place. So then we look for where the 2 match up to get this area. Now, something to keep in mind is when we use this table, and it's why they show us this picture up here, is that it's always area to the left. So what we'll do in this video is go through examples of finding area to the left, area to the right, area between 2 values, to see how can we calculate those if we're only being given this area to the left. It's just when we have those other scenarios that aren't area to the left, we have some little extra steps that we need to take. All right, so let's look at the examples we'll talk about here. Get rid of that. So let's just look at area to the left. So say I want to look at this positive 1.52. So as soon as I see it's positive, I want to go to my positive z-score table. And then I'm just going to write my number up at the top here, 1.52. So what I'm going to do is first find my 1.5. So I go along the left-hand side of this table, I find my 1.5, which means the area that I'm looking for is going to be somewhere in this row here. Then to figure out which of those values to use, I want to use my tenths place of the 2. So I go over to the right until I find that tenths place of 2, and then I see where the 2 intersect, which is going to be at that 0.9357. And that's our area under the curve, 0.9357. Which means this probability would translate to a 93.57% chance. Then to make sense of these probabilities, you can always draw a picture too, because that's a very large probability. So I might just want to think, okay, if I had my standard normal curve, 0, 1, 2, -1, -2. What I'm doing is I have a cutoff score of 1.52, which is out here, and then I was looking for the area to the left. So from that picture I can see, okay, that is a really large area, so that large probability makes sense there. For this case of area to the left of a -2.10, I can then think about that picture first, just to get an idea of if I'm on the right track or not with my numbers, or kind of have an idea of the probability before it's calculated. So -2.10 is going to be actually out here even, beyond where I graphed, and then we want the area to the left. This should be a pretty small probability. So let's go to our table and see where -2.10 pops up. So I'm just going to clean that up for when we use that table again. All right, -2.1. So finding that along the left-hand side, so we have our -2.1. And then that last decimal place needs to be a 0, which is going to be this first column here. And that's all lining up at 0.0179. So if I go back to my question, it was a 0.0179. So there's a 1.79% chance, which is a very small probability, which matches up with the picture that we thought about first. All right, and then this last one for area to the left. Again, if I just think about my picture first real quick, my z-score is actually very close to 0, and then I want the area to the left. So I'm starting pretty close there, and then I want this area to the left. So in terms of an estimate, I kind of expect to be close to 50% here. That's looking pretty close to half of that bell-shaped curve. So with this question, I have a 0 in the ones place and a 0 in the tenths place. So when I go to my table for the positive, I'll be using this very first row here. So there's my 0.0. And then my last digit is the 0.06. So I have that 0.5239, which is again close to that 50%, just like I expected. So 0.5239, which is 52.39%. So finding area to the left, you just look up the number on the table, and then that number is your probability. Now, with area to the right, what we need to use is think about the complement. Because with these bell-shaped curves, again, the whole area adds up to 1. So if our table is only giving us areas to the left, so we'll have some cutoff score, and while we're interested in area to the right here, we can use that area to the left. The table is going to give us this area to the left-hand side, so what we need to do each time with area to the right is take 1 minus area to the left. So that'll be our extra step with these, is using complement. So looking for the probability that z is more than or equal to a positive 2.31, what that's going to look like visually is if we have our bell-shaped curve, and just get our number line going here, and we're at positive 2.31, so we're out here, and we want area to the right. So what we're going to do is look up 2.31 on the table, but for our calculation, we'll need to do 1 minus that value that we get out. So let's go to the table and look up positive 2.31. So positive, and then 2.3 is this row here. And then for our 0.01, we're coming down here. So that's a 0.9896. So that's the large region to the left-hand side, but we need the opposite of it. So we'll take 1 minus 0.9896, which is a 0.0104, which is going to translate to a 1.04%, which matches up with the picture that we drew of a very small area that we're calculating there. Let's do this with a negative value. So if we have our number line, we're at negative 1.43. So negative 1.43 is over here, and we want the area to the right. We have more than or equal to that number. So we can see is we should be getting out a pretty large area when we calculate this. But it's area to the right, so we need to do 1 minus, and then we can go to our table. So we'll go to negative 1.43. So not here, but our next table. So negative 1.4 is going across this way, and then our 0.03 is going to line up at that 0.0764. So 1 minus a 0.0764 for our calculation. And plugging that into the calculator, we'll get out a 0.9236. So a 92.36% chance, which large probability lining up with the picture we drew. So that's how we do calculations for area to the right whenever you want at least or larger than or equal to or just larger than. You'll have to do this 1 minus and then use the value from the table. Now looking between two values gets a little tricky. So what we're doing with this one is we're going to have our curve, and then we're going to have these two values kind of sectioning off the area that we want to look at. So what we need to do is get creative with how we only use areas to the left to do this. So let's even look at this picture for negative 1.4 up to a 0.75. So I have my curve and then I'm going 0, 1, 2, negative 1, negative 2. So we want to look from negative 1.4, which is about right here, up to a positive 0.75, which is about right there. And we want to eventually find the area between those two values. So I want to end up with all of this. So what we can use here is we have two numbers, and we will end up looking at both numbers on the table. And when we look at the numbers on the table, they'll give us the areas to the left. So in fact, let's grab those numbers. Let's grab the number that matches up with negative 1.40. So if we're just grabbing this value for the probability of being less than or equal to negative 1.40, going to our table, we'll be at that negative 1.4, and then we want the 0 value at the end. So we have this 0.0808. So we have this one area of 0.0808. And then let's go ahead and look up the value that matches up with 0.75 as well. So going to our positive table, and we have a 0.7, and then we want to go out to 5, so that's a 0.7734. So let's see how these areas come up on this table, or sorry, on this picture. So the 0.0808 is representing this area to the left-hand side here, which what we want to see is that we actually don't want to include that. We want to exclude that area. But it gives us an idea of how much we want to exclude. So when we look at the 0.7734, what that area represents is everything to the left of the 0.75. So we have is this large area that's been calculated. And to get the area that we're actually interested in, it's like we want that 0.7734, but we want to exclude that area that's to the left of the negative 1.4. So we want to take out that area of 0.0808, because then that will leave us with just the area in between the two values. So visually what we're doing here, just to kind of see what we have in terms of the subtraction, is we start with this whole area to the left of 0.75, but then what we do is take out this area to the left here, so that we only have that area left over between negative 1.4 and 0.75. So if we carry out that calculation, 0.7734 minus 0.0808, that's a 0.6926, which is 69.26%. So with these cases of looking between two values, you'll have to use the table twice. You'll always have a larger x value and a smaller x value. So what you want to do is use the table and take area left of your larger value, so I'll call that x2, and then subtract out the area to the left of the smaller x value, or z-score really is our letter that we're using. So that's the basics of using the table. What we're going to do in the next video is see how we get our z-scores first, but then we'll use the table to carry out our calculations.